Alright, today we're going to do problems that are the optimization problems, so some story problems, and what I have for you is a strategy I want you to follow. So the first thing we're going to decide to do before we approach any problems is decide what's going to be maximized or minimized. We're going to draw a picture if possible. The next thing we're going to do is list appropriate equations. The next thing we're going to do is write the equation to be maximized or minimized as a function of one variable. And then we're going to find those critical points and answer the question appropriately. Make much more sense as we work through a problem. So this one's not a real world problem or anything like that. It's just going to give us a chance to work with those rules. So I'll go back and forth between those rules. So the first rule says decide what is to be maximized or minimized. We're not going to draw a picture on this one. The product is 192 and the sum of the first plus 3 times the second is a minimum. So we want to minimize, right here we're going to minimize the sum. So I'm going to go and write that down, that we're going to find the sum as a minimum. That's step 1. Step 2, what's the appropriate equation? Back to this problem. I have a product of 192. I have no idea what these two positive numbers are, so I'll call them x and y. The product would be x times y equals 192. And then the second equation would be the one dealing with the sum. The sum of the first plus 3 times the second. So I'll call the first one x. And 3 times the second is a minimum. We have no idea what that sum is, so I'll just call it an s. The third step, write the equation to be maximized or minimized as a function of only one variable. This function right here is the one that's supposed to be minimized. We wrote that right here. So what we're going to need to do is write this as a function of one variable. We'll want it to be s equals either all x's or all y's. I'll go ahead and just simply solve for x over here. So I get 192 divided by y. So I'm going to replace my x with this 192y plus 3y. And I'll be ready to minimize this, which means I'm going to be taking the derivative of it. I'll be taking the derivative of it with respect to y. So I'm going to rewrite the s first as 192, y to the negative first plus 3y. Now I'm ready to take this derivative. The derivative would be negative 192, y to the negative second plus 3. Minimums and maximums occur at critical numbers. So once we have written that as a function of one variable, we find the critical numbers, which means we have to find the derivatives. So I need to set this equal to 0. And then I will move the 3 to the other side. And I will cross multiply and I will end up getting 192 equals 3y squared. They will be both positive. I have to come up here to finish this. So I get 192 divided by 3 y squared. That actually equals 64. So when I square root both sides, I do get plus or minus 8, but we're only going to talk about the positive number, so I'll only write down 8. The next thing I want to do is I want to answer the question, and the question is, find the two positive numbers. So I found one of the numbers. One of the numbers is 8, and then the x number can be figured out by plugging that back into the x equals equation right here, 192 divided by 8. So the x value would be, x would be 24. Now, had it asked me to find the minimum sum, I would have just added those together. So the minimum sum, just for the fun of it, the minimum sum would be 32. There wasn't really any endpoints to check on this because there wasn't any stop or starting value other than the positive numbers. We'll discuss more about the endpoints. There'll be more. You'll see them more in other problems. For the next problem, it says a rancher has 200 feet of fencing with which to enclose two adjacent rectangular corrals. You can see the picture that was given. What dimension should be used so that the enclosed area will be a maximum? Using my strategy, the first thing I'm supposed to do is figure out what's to be maximized or minimized. So if I go back to here, it says that we want the area to be a maximum. So I'm going to maximize or find maximum area. The second part of my strategy is appropriate equations. Well, I know I need to use 200 feet, and what that refers to is it's telling me that I have 200 feet to cover all these red lines. So I have x, x, and y. So I have to put 4 x's and 3 y. The second equation has to do with what I'm supposed to be maximizing or minimizing, in this case maximizing the area. This side has a length of 2x, so the area would be 2x times y. I am going to do the third part, which is to write the equation to be maximized and minimized as a function of only one variable. So I'm going to go ahead and solve for y on this problem. When I solve for y, I end up getting 200 minus 4x equals 3y. Divide by 3. And I end up with this y value. That will allow me to come over here and write this function as a function of one variable, 2x times, instead of the y, I'll have 200 minus 4x over 3. I don't really want to take the derivative of that yet because it's going to find the critical points, and I know that means I have to find the derivative. What I want to do is I don't want to end up having to do a product rule, so I'm going to distribute this through. So that gives me 400x minus 8x squared over 3. Now I don't really like this 3, but it's really just a constant of 1/3, so I'll pull it out front. And then if I want to even, I could take out an 8, which I will go ahead and do. So I now have the area of the equation to be 8/3. And then that would be 50x minus x squared. Now you might be wondering, why didn't I pull out an x2? Well, then I'd be back to doing a product rule. And by just pulling out this constant, I'll be able to figure out my first derivative. And when we take the first derivative and we have a constant out front, we can just write it. So it actually just makes things a little bit easier. So what I'm going to end up getting here when I take the derivative of what's inside is 50 minus 2x. So I'm going to set this equal to 0. And what I then can do, I can really get rid of this fraction, because when I divide by 8/3 on both sides, I get 0. Move the 2x over, and I get my x value is 25. So what that's basically telling me is when x is 25 is the maximum, supposedly. You really should check your critical numbers to make sure that it's a max. So I will go ahead and do that in this problem. If I plug in, let's just plug in 1, that would be to the left of this. I don't want to plug anything lower than 1 because 0 would be considered one of those endpoints. And endpoints in this problem, which it does say check the endpoints, doesn't make any sense because if you have 0 amount of fencing, you're going to end up with 0 amount of area. That doesn't make any sense. We're not going to use 200 feet of fencing on just the X parts because then we'd have no Y parts. So again, this is one of those problems where the endpoints don't make a whole lot of sense. So when you plug 1 into your derivative here, you end up getting 50 minus 2, which is positive. And then when you plug in maybe like 26, you get 50 minus 52, which is a negative. So you can see it's increasing and decreasing. So this is definitely a maximum. The question they'll ask you to find the dimensions. So the x dimension is 25, and we're yet to find the y dimension. We're going to find the y dimension by plugging it back in right here. So when I plug that in, I get 200 minus 100 over 3, which gives me a y value of 100 over 3. Those would be the two dimensions that give us the maximum area.